morning, students. In last class we have discussed about the Laplace transformations, various properties of Laplace transformations. Today we will discuss about the Laplace transformation of the derivatives and the Laplace transform of the integral functions. So, Laplace transform of derivative. It says that if a function fx is such that first fx is continuous for x lies between 0 and n. Second, fx is of exponential order, gamma for x greater than n. And third, f dash x is sectionally continuous for x lies between 0 and n. And fourth, Laplace transformation of fx with respect to p is equals to fp. Then the Laplace transformation of f dash x with respect to parameter p, this is equals to p fp minus f0. The Laplace transformation of first derivative f dash x of fx is given by pfp minus f0. The function is such that fx is continuous, fx is of exponential order for gamma, fx is of exponential order gamma, and f dash x is sectionally continuous. Then Laplace transformation of f dash x with respect to p, this is equals to pfp minus f0. The proof for this one, we see that we find the Laplace transformation of f dash x with respect to parameter p. If we use the definition of the Laplace transformation, then this is equals to integral 0 to infinite e raised to minus px f dash x dx. If we integrate the right hand side by parts, we get this is equals to h. Integrating this one as e raised to minus px fx, the limits from 0 to infinite minus integral 0 to infinite minus p e raised to minus px fx dx. Or we can write it as limit x tends to infinite e raised to minus px fx minus limit x tends to 0 plus f of 0 e raised to limit x tends to 0 plus e raised to minus px fx minus plus p integral 0 to infinite e raised to minus px fx dx. Since the function fx is of exponential order gamma, so this value limit x tends to infinite e raised to minus px fx comes to be 0, and limit x tends to 0 plus e raised to minus px fx comes to be the right hand limit f plus 0. So calculating this one, we get this is 0, this is minus f plus 0, and this one is plus p. Integral 0 to infinite e raised to minus px fx dx is nothing but the Laplace transform of the function fx. So we take the Laplace transformation of the function fx as fp. So this is p f p. Since the function fx is given as the continuous function, so its the right hand limit f plus 0 is equals to the functional value f0. So this can be written as pfp minus f of 0. So the Laplace transformation of f dash x with respect to parameter p is given as pfp minus f0. If we generalize this one, we get the Laplace transformation of fn x with respect to p is equals to pn fp minus p raised to n minus 1 f of 0, p raised to n minus 1 f of 0 minus p raised to n minus 2 f dash 0, and so on, and last one is f raised to n 0, f raised to n minus 1 0, sorry. So on generalization, we get the Laplace transformation of the nth derivative of the function fn x is equals to fn p raised to n fp minus p raised to n minus 1 f0 minus p raised to n minus 2 f dash 0, and last term is minus fn minus 1 0. So these are the Laplace transformations of the function, its derivative, first derivative, and its nth derivative. Now if we find the Laplace transformation of integrals, we have to prove the Laplace transformation of integral 0 to x f of u du with respect to p. This is equals to fp upon p. So we have to prove the Laplace transform of the integral 0 to x f of u du with respect to p, and we have to prove that this is equals to fp upon p. The proof of this one, if we let integral 0 to x f of u du is equals to gx. If we take gx is equals to integral 0 to x fu du, then g dash x is equals to f of x and z0 is equals to 0. If we put the value x is equals to 0 in gx, then we get g0 is equals to 0. So now we take the Laplace transformation of g dash x, Laplace transformation of g dash x. By the definition of the Laplace transformation of the derivative of the function, we get this one as the Laplace transformation of, this is pgp minus g0. gp here, gp is the Laplace transformation of the function gx. So we get, as we know that the g dash x is equals to fx. So putting these values, we get the Laplace transformation of fx with respect to parameter p. This is equals to p, the gp. Gp here is the Laplace transformation of gx. The Laplace transformation of gx with respect to parameter p minus z0. Here z0 is 0. So solving this, we get the Laplace transformation of fx. As we know that Laplace transformation of fx with respect to parameter p is fp. This is equals to p Laplace transformation of gx. Gx we have taken as gx as integral 0 to x f of u du with respect to parameter. So here by solving this, we get the Laplace transformation of integral 0 to x f of u du with respect to parameter p is equals to fp upon p. So we get the Laplace transformation of the integral function integral 0 to x f u du. This comes to be as fp upon p. So today we have find the Laplace transformation of derivative of a function and the Laplace transformation of the integral of the function. Thank you very much.